Hi class, today we're going to be reviewing the Trig 6 test review. All of these questions are pretty reflective of what's on the test, so let's get started. First question asks us to find when cosine squared of x is equal to 1. Now remember, when we're solving, we're looking for something that we can plug in for x that makes this a true statement, that makes this trig ratio squared equal to 1. So what I'm going to do is I'm going to take the square root of both sides of the equation. So I'm going to take the square root of the cosine squared of x and the square root of 1. Okay? So what happens is if you take the square root of cosine squared of x, you end up getting the cosine of x equals to plus or minus the square root of 1. And the reason why that's true, I keep referencing this example in class. So here's my side note here up to the right. If I have x squared is equal to 4, the two things that x can be are both positive 2 and negative 2. Positive 2 squared is 4, negative 2 squared is 4. So the reason why that's true is if you take the square root of both sides, kind of take the absolute value of x is equal to 2. Absolute value meaning both positive and negative 2 work. All right, so back to my real problem. So if the cosine of x is equal to plus or minus the square root of 1. So my two answers are the cosine of x is equal to positive 1, square root of 1 is 1, and the cosine of x is equal to negative 1. So the next step in this process, it requires us to kind of reference, if you remember the Trig 2 test. So we are looking for some angle of rotation x that can rotate to where cosine of x is equal to 1. So I just want to remind you guys, over here on my side note again, the cosine of any angle theta is always equal to the x coordinate on an axis. So I hope at this point we're noticing that the cosine of x or the sine of x equal to 1, negative 1, 0, those are going to end up with a quadrantal angle. So what I'm going to do is I'm going to look for where the cosine of this angle x is equal to 1. So I'm looking for where the x value is 1. Well, the x value is 1, the only place is right here, which happens to be a 0 degree angle or 0 radian angle. So then if I'm looking for where cosine of x is negative 1, cosine of x is negative 1, over here, this point over here is negative 1 comma 0. So the x coordinate of this angle is negative 1. So the angle that gets me there, the angle of rotation, is pi. So the two solutions of this problem are 0 and pi. Next, I'm going to solve a very similar problem, but this time with the sine squared of x. Okay, so I'm going to do that same exact process. I'm going to take the square root of both sides, which gives me the sine of x is equal to plus or minus 1. So I'm going to write those as two separate equations. Sine of x is equal to positive 1, sine of x is equal to negative 1. And then similarly to the last problem, I need to find what angle of rotation, what angle for x satisfies the sine of x being 1 or the sine of x being negative 1. So I do want to remind you guys, here's another side note over here to the right, that the sine of any angle theta is always equal to the y coordinate. So hopefully we're recognizing these quadrantals. So if sine of x is equal to 1, the only place where the y coordinate is 1 is this point here. The angle that gets me there is pi halves. Okay, where the sine of theta is equal to y for negative 1, so where sine of theta is negative 1, it's down here. It's on that bottom half of the y-axis, 0 comma negative 1. So the angle that gets me there, that angle of rotation, is 3 pi halves. So the two solutions to the sine squared of x is equal to 1 are pi halves and 3 pi halves. Next up, we have the tangent squared of x minus 1 is equal to 0. So my strategy I'm going to use for this problem is I'm going to factor. I'm noticing that this is the difference of two squares, so I can factor each individual perfect square into both tangent of x, and minus 1 and plus 1. Okay, so this is the difference of two squares. The next thing I'm going to use something called the zero product property. So I'm going to say that the tangent of x minus 1 is equal to 0, and the tangent of x plus 1 is equal to 0. Okay, so it's a little bit different of a process than I used for the previous two. But we're going to end up getting kind of the same result, where one of our answers is going to be positive and one of the answers is going to be negative. So let's look. So on the left side here, I'm going to add 1 to both sides. I have the tangent of x is equal to 1. On the left side here, I'm going to subtract 1 from both sides. I end up with the tangent of x is equal to negative 1. Okay, so now the tricky part for this is that the tangent of x being equal to 1 that is actually a triangle. It is not a quadrangle. So we're still looking for that angle x that rotates to where the tangent of x is equal to 1. But I want you to remember that 1 can always be placed over 1, meaning I'm looking for where the tangent of x is equal to 1 over 1, where my opposite side is 1 and my adjacent side is 1. I'm trying to find an angle of rotation that satisfies this ratio of sides. So how I do that is I start by limiting which quadrants I'll be located in, and it's going to be 2 of them. So because I'm looking at a positive 1, I need to cancel off the top left quadrant, quadrant 2, and the bottom right quadrant, quadrant 4, because the tangent is negative there, and I know that the tangent of x is a positive 1 over a positive 1. Okay, so the next step then, draw on your reference triangles, guys, in those 2 quadrants. I'll try to be a little neater than I just was. Make your opposite side 1, your adjacent side 1. I hope that we recognize this as a special right triangle with an angle of rotation of pi fourths, which means this other triangle here is also going to have a reference angle of pi fourths, so the angle of rotation that gets me there, in this case, is going to be 5 pi fourths. So 2 of my solutions are pi fourths and 5 pi fourths. Next, I'm going to find the tangent of x is equal to -1, so this is the right side of the problem. So I found the left answers here, pi fourths and 5 pi fourths. Now I need to find that the tangent of x is equal to -1. So if all students take calculus, I'm actually going to be in the second and the fourth quadrants now that my tangent is negative. So let's draw on our reference triangles. Let's label those sides. So my opposite side is +1. My adjacent side is -1. In the bottom right quadrant, my opposite side is -1 and my adjacent side is +1. I want to be clear about that. -1 over +1, same exact thing as 1 over -1. Either one works in this case. Okay, so hopefully we recognize that this is a special right triangle. So 1 square root of 2. So my reference angles are going to be pi fourths. So what angle of rotation gets me there for both of these reference triangles? In that top left quadrant, x is going to be 3 pi fourths. For the bottom right quadrant, x is going to be 7 pi fourths. All right, for this next question, we have the cosine of x minus 2 is equal to 0. I'm going to start by adding 2 to both sides. I'm going to try to isolate my variable. So what do I do next? Well, I have to realize that the cosecant of x is equal to 2. Okay, so I know that the cosecant of x, it's always my hypotenuse over my opposite side, right? So cot-TOA, cosecant is the reciprocal of sine. Therefore, if the sine's opposite over hypotenuse, the cosecant will be hypotenuse over the opposite side. So you do need to kind of realize that 2 is the same thing as 2 over 1. Okay, so now that we know that the cosecant of x is equal to 2 over 1, I'm going to make sure to cancel off or x out the quadrants where the sign is negative. So the sign is negative in the bottom 2 quadrants. So then I'm only going to draw triangles in the top 2 quadrants. Okay. So if my hypotenuse is 2 and my adjacent or my opposite side is 1, I should be recognizing this as a pi thirds, pi sixths, pi halves triangles. So that means that this angle here must be pi sixths. So one of my solutions is pi sixths. Okay, so the other one, my opposite side is going to be 1, my hypotenuse is going to be 2, adjacent side square root 3. It's actually negative square root 3. So that means that this reference angle here is pi sixths. Angle of rotation that gets me there is going to be 5 pi sixths. So the 2 solutions of this problem are pi sixths and 5 pi sixths. I'm going to stop for a second and I'm going to talk about number 3 and 4 in the context of extraneous solutions. So there are 2 situations in which you might have an extraneous solution. Okay, the first situation, if sine or cosine is on a denominator. So in this case, for both 3 and 4, and 1 and 2, we don't have any denominators written. All we have is the tangent squared of x, and we have the cosecant squared of x, or cosecant of x. Neither has a sign on the denominator. The second situation, if any other trig ratio is in your function, or your equation, I'll say, besides sine or cosine, you need to check for extraneous solutions. So for example, in this bottom one, I know that I have a cosecant of x. The cosecant of x, that's the same exact thing as 1 over the sine of x. So we do need to find where the sine of x is not equal to 0. So if you think about where the sine of x is not equal to 0, you can kind of draw on your coordinate grid and like, where's that y coordinate 0? Oh, here and here. So those angles that x can't be are 0 and pi. The two angles that get me to a place where my y coordinate is 0. 0 and pi for sine. Okay, so just double check in your problem. Is 0 or pi, is either one of those angles involved in your solution set here? There's not, but I am glad we checked. Just in case there was, we would have to call them extraneous solutions, which we'll see in a sec. Okay, so number 5 and 6 really are the same type of problem as number 1, 2, 3, and 4, just the algebra to get you to the place where you can solve the trig function is a little tougher. So let's talk about that. So when you undo, solving steps, you really want to undo like reverse PEMDAS. So in this case, the first PEMDAS step I have to undo, or that I have next to my x, is like a multiplication of 8. The way I undo that is divide by 8. So if I divide both sides by 8 here, I get the cosine squared of x is equal to 2 divided by 8. That's the same thing as 1/4. And I'm just simplifying that fraction. 2 over 8 becomes 1/4. Okay. The next step here, I'm going to undo. So I did my multiplication. Next, I'm going to undo my exponent. So I have an exponent of 2 there. So let's square root both sides. So what we end up with is the cosine of x is equal to, remember that plus or minus, we undid a squared, the square root of 1 over the square root of 4. And then I'm actually going to simplify this a little more. Cosine of x is equal to plus or minus 1 over 2, 1/2. Square root of 1 is 1, square root of 4 is 2. So now that I know my cosine of x is equal to plus or minus 1/2, I can actually consider that I'm actually going to have all of my reference triangles in every single one of my quadrants. Because if the cosine of x is equal to a positive 1/2 and negative 1/2, we will have a reference triangle in every single quadrant. So let's label our sides. Now remember, cosine adjacent over hypotenuse, adjacent side is 1, hypotenuse is 2. That means that my third side is the square root of 3. If you want to, at this point, you can probably just assume the rest of the triangles are going to be the same exact thing, but I'm going to label them, be a little extra here. Okay, so then what angle gets me there? If that's a square root of 3 opposite side and a 1 is an adjacent side, that angle of rotation for that first triangle is going to be pi sixths. The second triangle is going to be 5 pi sixths. Third triangle is going to be 7 pi sixths. And the fourth triangle is going to be 11 pi sixths. So I'm going to have pi sixths, 5 pi sixths, 7 pi sixths, and then 11 pi sixths. And then I want to be clear, I do not need to check for extraneous solutions because neither of the two criteria that require me to check exist for this problem. We don't have any cosine or sines in the denominator. We don't have a tangent, a cotangent, a secant, or a cosecant in my equation. Alrighty, for this next one, I think the most difficult part about this problem is seeing how to factor it. Okay, so what I'm going to do over to the right here in blue, I'm going to do another side note, and I just want to reference this idea of having like 3x squared plus 6x is equal to 0. How would we factor that? Well, we would factor out a GCF. Both 3x squared and 6x have a GCF of 3x. So what's left over if I divide out a 3x from both of these? Divide out, I'm left with x plus 2. So then if I wanted to solve this further, I could state that zero product property, 3x is equal to 0, and x plus 2 is equal to 0, which means my two solutions are 0 and negative 2. Okay, so the reason I went over that algebra review is because in this problem, we need to factor out, so I'm back here, I need to factor out a cosine of x. Both of these parts of my equation have a GCF of cosine of x, so I'm going to factor out a cosine of x, divide it out from both parts of my polynomial, and I'm left with 2 cosine of x plus 1. Then I use the zero product property. I state that the cosine of x is equal to 0, and I state the 2 cosine of x plus 1 is equal to 0. And then I solve those individual parts. So luckily on the left side there, the cosine of x is equal to 0. That's already solved for us. On the right side, a little bit solving there. Subtract 1 first, then divide by 2. So we end up with the cosine of x is equal to negative 1/2. Okay, so now we bring in our triangle. So what angle of rotation satisfies cosine of x being 0? So if you remember, the cosine of theta is always equal to the x coordinate on that grid. So where's the cosine of x? 0, or where's that x coordinate 0? It's going to be 0 at pi halves and 3 pi halves. So if you look at the grid here, 0, 1, 0, comma, negative 1, that's where your x location is 0. So two of my solutions are pi halves and 3 pi halves. Okay, so for this other piece, the cosine of x is equal to negative 1/2. Well, if all students take calculus, I know that not going to be in the top right quadrant because all of my trig ratios are positive there. It's not going to be in the bottom right because the cosine is positive there. And my trig ratio is equal to negative 1/2. So my two reference triangles are going to be in the second and third quadrant with an adjacent side of negative 1 and a hypotenuse of 2. Therefore, this opposite side must be the square root of 3. So my angle of rotation to get me to this special right triangle, one of them, the one that goes to the second quadrant, is going to be 2 pi thirds. And then the next one is going to go to this third quadrant. That's going to be 4 pi thirds. So my four solutions to this problem are pi halves, 3 pi halves, 2 pi thirds, and 4 pi thirds. And once again, I don't have to check for any extraneous solutions because I don't have any denominators with a cosine or a sine. I don't have any of the other trig ratios. Next up, I first am noticing in this problem, I have a denominator of the sine of x. So I know, this is the first one on this review, that I have to check for extraneous solutions. The way I do that is I ask myself, where is that denominator, the sine of x, not equal to 0? Okay, so for the sine, if you think about the y coordinate being 0, the y coordinate is 0 at 1, 0 and negative 1, 0. In other words, it's 0 where x is 0 and pi. So at the end of my problem, I got to make sure 0 and pi are not solutions. And if they are, I got to cross them out. Okay, so back to my problem. So the cosine to the third power of x minus cosine of x is on the numerator. I'm going to get rid of that denominator by multiplying both sides by the sine of x. And usually that's like a kind of a big no-no, just like getting rid of variables. But in this case, it's okay because we know we already checked for where that sine of x is like equal to 0, or rather not equal to 0. Okay, so then from here, we need a factor. Okay, so I have the cosine to the third power of x minus cosine of x. I'm going to factor out a cosine of x to start with, and I'm left with cosine squared of x minus 1. Then I'm going to factor the cosine squared of x minus 1 into the cosine of x minus 1, cosine of x plus 1. And then I'm going to use the zero product property. So where is the cosine of x equal to 0? Where is the cosine of x minus 1 equal to 0? And where is the cosine of x plus 1 equal to 0? So for the first one, the cosine of x is equal to 0. So where is like the x coordinate equal to 0? At pi halves and 3 pi halves. So my two solutions initially are pi halves and 3 pi halves. Okay, what about this next one? So I'm going to add 1 to both sides. So I've got the cosine of x is equal to 1. Okay, so if I look where the x value is 1, I think the x value of 1 is only at that first location where x is 0. And then the last example here, cosine of x minus 1, or cosine of x is equal to minus 1, or negative 1 rather. We're looking for that x value is negative 1, which is right here, where x is pi. So I have four solutions, but if you remember at the beginning of the problem, we stated, and I'm going to highlight this here, that x, it cannot be equal to 0 or pi. So on my paper, I have to cross out those two solutions and write the word extraneous. All right, last one. We have an algebraic equation, and luckily it's linear. So what I mean by that is there's no squareds involved. So what we do to start with this problem is we're going to get all of my signs on the same side and all of my numbers, normal numbers, on the other side. So let's start by subtracting 2 sine of x from both sides. Notice I'm kind of lining it up with the other sine of x. And then I'm also going to subtract 2 from both sides. So what I end up with for sine of x minus 2 sine of x is 2 sine of x. 2 minus 2 is 0. 2 sine of x minus 2 sine of x is 0. And then 3 minus 2 is 1. And then I'm going to divide both sides by 2. So I end up with the sine of x is equal to 1/2. Okay, so if I look on my grid, where is the sine of x equal to 1/2? Well, that's a positive 1/2. So if all students take calculus, I'm not going to have any trig ratios that exist in this bottom two quadrants. That's where the tangent and cosine are positive. Okay, so let's draw on our reference triangles. Label your sides, opposite 1, hypotenuse 2. That means that my adjacent side is the square root of 3, special right triangle. Okay, so what angle is this? I think it's a pi/6 angle. So one of my answers is pi/6. And then what's the other answer? That's going to be 5 pi/6, right? What gets me, what rotates to a pi/6 angle. Okay. All right, so my answers to this are pi/6 and 5 pi/6. And luckily for number 8 here, we don't have any extraneous solutions. There's no denominators. There's no other trig ratios besides sine.